Welcome back to the deep dive. Today, we are really getting into the nitty-gritty of business strategy.
We are. We're not talking about gut feelings or, what worked last year.
No, none of that. We're focusing on one single, incredibly powerful tool, the cost-volume profit equation. People just call it CVP.
And it really is the skeleton key. It provides this fundamental structure for understanding how changes in your costs and your sales volume are going to affect your profit.
So our mission for this deep dive is to take this, core accounting concept and make it a practical tool you can use for pretty much any strategic decision.
Exactly. It takes a whole mess of data points and just organizes it. You plug in the numbers and you get clarity instantly.
And the simple version of the equation is something everyone already knows, even if they don't realize it. It's just sales minus variable costs minus fixed costs equals profit.
Right. It's that simple. But for a real business, we have to break it down a bit more.
Okay.
Sales and variable costs aren't just one number. Sales is your price per unit times the number of units you sell.
And variable costs would be your cost per unit. Again, times the number of units.
Exactly. And the fixed costs, like your rent or salaries, they just stay, well, fixed.
And this is so critical for figuring out your break-even point, right? That's just when profit equals zero. It's your starting line.
It is. Once you're past break even, every single sale starts adding to your bottom line.
Okay, so to make this real, let's use a foundation example. We're going to be talking about a fictional company called Jules that makes baseball gloves.
A classic manufacturing operation. So the initial numbers are pretty straightforward. The selling price for one glove is $200.
Okay.
The variable cost to make that glove, the labor, is $110. And the total fixed costs for the factory are $63,000.
Got it. So that's our baseline. We're going to use these numbers to test a bunch of different strategic challenges.
That's the plan.
All right, so let's unpack this. Before we start running any scenarios, there's one piece of this puzzle that's just absolutely critical, the contribution margin.
Yeah.
CM, what is it and why does it matter so much?
The contribution margin is just the difference between your selling price and your variable cost for one unit.
So in this case, $200 minus $110.
Right, which gives you $90. And that $90 is the key. It's the amount of money each glove sale contributes to covering your fixed costs. And then after that, to profit.
So every time we sell a glove, we get $90 to pay down that big $63,000 fixed cost bill.
Exactly. It's the fuel for the whole operation. Everything left over after the fixed costs are paid is pure profit.
Okay, that makes sense. Let's jump into our first scenario. Let's say our fixed costs go up.
Right. Maybe property taxes went up or you launched a big ad campaign.
Yeah. So our total fixed costs increase from that initial $63,000 all the way up to $81,000. And on top of that, management wants to hit a target profit of $36,000.
Okay, so this is a classic target profit problem. The question is, how many units, let's call it X, do we need to sell?
So how do we set up the equation?
Well, you need to generate enough contribution margin to cover both the fixed costs and the profit you want.
So you add them together.
You do. You take the $81,000 in fixed costs, add the $36,000 in target profit. And that means you need a total contribution margin of $117,000.
Got it. That's the total we need. And since we know each glove gives us $90.
You just divide.
Yeah.
$117,000 divided by $90 per unit.
And that gives us a nice, clean 1,300 units.
It does. But here's where we have to pause. You should always operate on the principle of trust, but verify.
Right. You can't just throw the number over the fence to management. You have to be sure it's right.
Exactly.
Yeah.
So let's do a quick check. If we sell 1,300 units and each one contributes $90, that generates $117,000 in total CM.
Okay.
You subtract the $81,000 in fixed costs from that, and you are left with exactly $36,000 in profit.
It checks out perfectly. That gives you confidence in the answer.
It really does.
All right, scenario 2. Let's look at what happens when our variable costs change. Let's say our leather supplier raises their prices.
Very common problem. So our variable cost per glove is going to jump from $110 to $130. For this one, we'll put fixed costs back to the original $63,000.
But we still want to hit that same $36,000 profit target.
Okay. So the first thing that happens here is a direct hit to our contribution margin.
Oh, yeah. The price is still 200, but now the cost is 130. Our CM just dropped from $90 to 70.
It's a huge drop in efficiency. Now each glove is contributing less.
So same process. We
Mhm.
need to cover the 63,000 in fixed costs plus the 36,000 in profit.
Which means we need a total of $99,000 in CM.
And we take that 99,000 and divide it by our new lower unit CM of $70.
And when you run that math, you get,
Yeah.
well, you get a messy number, 1,414.285.
Right. And here's the problem. You obviously can't sell a fraction of a baseball glove.
You can't. So you have to make a decision. Do you round down or round up?
And if you round down to 1414, you'll miss your target, right? Even if it's just by a little bit.
You'll fall just short. So the standard rule, the convention here, is that you always round up to the next whole unit.
So 1,415 units.
That's the answer. And if you check it, selling that many units actually gives you a profit of $36,050.
So you beat the target by 50 bucks.
Right. That's the price of guaranteeing you meet the goal. It's a critical little detail.
Okay, let's look at the flip side. Scenario 3. What if we can raise our prices?
A much happier scenario.
Let's say we increase the selling price from $200 to $230 per glove. Variable and fixed costs stay at their original levels.
So our new contribution margin is $230 minus $110.
$120. That's a huge jump. We're keeping a lot more from every sale.
A much more efficient operation. Now let's see what that does to the unit count. We still need that $99,000 in total CM,
Okay.
but now we're dividing it by $120 per unit.
The math there is
Oh.
only 825 units.
And this is where it gets really interesting, where you move from just math to actual strategy.
Right. Compare that to the last scenario. We needed over 1,400 units when our variable costs went up by 20 bucks.
Almost 600 extra gloves.
But increasing our price by $30 just slashed the number of units we need to sell.
And that's the strategic insight. Your contribution margin is the most powerful lever you have. Small changes there have a massive disproportionate effect on the volume you need.
But wait a minute. This is where the real world comes in. That 825 number looks great. But if we jack up the price to $230, won't we lose customers?
That is the perfect question.
How does the equation account for that risk?
It doesn't. And that's the key thing to understand. CVP is not a market forecasting tool. It's an internal analysis tool. It tells you if you can sell 825 units at this new price, you will hit your target.
So it sets the hurdle.
Exactly. The risk assessment, the qualitative judgment of whether the market will actually let you sell that many, that's management's job. They have to layer that on top of the hard numbers.
That makes perfect sense. Okay, now let's get into some more complex trade-offs. This is where it gets really powerful.
This is where it really shines, yeah.
Scenario 4. Management is thinking about a strategy with multiple moving parts. They want to lower the price to grab market share.
A classic volume play.
But doing that is going to require more marketing spend, so fixed costs are also going up.
Okay, let's track all the changes. Selling price drops to 180.
Okay.
They expect sales volume to jump to 1,600 units. But fixed costs also go up to 83,000. Variable cost stays at 110.
So the goal here isn't to find the number of units. The goal is to calculate the final profit and see if this whole plan is even a good idea.
Right. First, what's our new CM? 180 minus 110.
$70.
So we plug it all in. $70 CM times 1,600 units minus the new fixed costs of 83,000.
Okay, 70 times 1,600 is $112,000 in total CM.
Mm-hmm.
Then we subtract the $83,000 in fixed costs,
Right.
and we're left with a profit of $29,000.
And there's your answer, $29,000. Now, management can look at that number and decide. If their original plan was going to make them $35,000, this is a bad move, even if selling more units feels good.
It puts a hard number on a gut feeling.
They love that.
Okay, one more complex trade-off. Scenario 5.
Let's do it.
This one is a classic dilemma. Using cheaper materials to save on costs.
The quality trade-off.
So we're going to drop our variable costs. But we're worried about quality control, so we're going to increase fixed costs by hiring an extra supervisor to watch the new process.
A very realistic scenario. Let's look at the numbers. Selling price stays at 200. We think we can sell a bit more, maybe 1,100 units.
And the variable cost drops from 110 down to an even 100.
But fixed costs go up to 68,000 to pay for that new supervisor.
Okay. So our new contribution margin is fantastic. $200 price, $100 cost. That's $100 CM.
That's a 50% CM ratio. Half of every dollar in sales is pure contribution,
So the calculation is $100 CM times 1,100 units,
which is 110,000 in total CM.
minus the 68,000 in fixed costs. That gives us a profit of $42,000.
And again, there's your answer. Instead of debating whether the cheaper materials are worth it, you have a number, $42,000. CVP validates the trade-off.
It's so clear. Now, to really drive this home, let's apply this same logic to a totally new product. Let's talk about baseball bats.
Great. And let's add one more layer here, something called the contribution margin ratio.
Ooh, okay. What's that?
It's just your CM per unit divided by your selling price per unit. It tells you what percentage of every single sales dollar goes towards covering fixed costs and profit.
Interesting. So you can think in terms of total sales dollars, not just units.
Exactly. So for the bats, the new data is selling price is $90, variable cost is $45, fixed costs are $40,000, and the target profit is $25,000.
Okay, so the CM per unit is easy. 90 minus 45 is $45.
And to get the CM ratio, you take that $45 CM and divide by the $90 price.
Which is 0.5 or 50%. So for every dollar of bat sales, 50 cents is contribution.
You got it. So first, let's find the number of bats we need to sell the old way.
Right. We need to cover 40,000 in fixed costs plus 25,000 in profit. So 65,000 total CM.
We divide that $65,000 by the $45 unit CM, and we get 1,444.44.
And following our rule, we round up to 1,445 bats.
Perfect. Now, what if management asked for the answer in sales dollars instead of units?
This is where the ratio comes in.
Yep. We know we need 65,000 in total contribution, and we know that's 50% of our sales. So we just divide 65,000 by 50%.
Which gives you $130,000 in required sales revenue.
And it checked out. If you sell 1,445 bats at $90 each, you get $130,050. The structure is totally portable.
That's incredible. It works perfectly whether you're thinking in units or in dollars.
And that final plan yields a profit of $25,025, so we know it works.
So, after all that, what does this all mean? We went through 5 totally different scenarios, and one single equation gave us a clear, structured answer every single time.
I think there are 2 big lessons here. First, just get really comfortable with the CVP structure. Confidence comes from knowing the framework. Once you know where the numbers go, the analysis is methodical.
And second, and I can't stress this enough, always, always check your work.
Yes.
That verification step is what catches little algebra mistakes, but more importantly, it's what gives you the confidence to trust your final answer.
It absolutely is. And that confidence lets you tackle really complex scenarios. Think about that trade-off with the cheaper materials and the extra supervisor. The CVP equation handled that simultaneous change with no problem.
So here's something to think about. If this framework can be used to evaluate any decision that involves a change in costs or sales, how could you use it to pre-test a business strategy before you even spend a single dollar? It basically turns every potential investment into a testable hypothesis. You don't have to guess anymore. You can calculate.